Shall I close this? This one. Get people joining. Hi, good evening, everyone. We will start in 2 to 3 minutes. I hope my voice is clear.
Yes,
You are.
Hi Siva, very good evening. Yes,
Yeah, good evening, Lokesh.
Hi, good evening.
hi.
Hello, we will start in few minutes, just 2 more minutes. Hello, we will start in.
Okay.
Deploying process.
Okay, so we can start the session. I'm sharing my screen. I hope you can see the screen. Can someone please confirm?
Yes, we can.
Okay, so my voice is audible and my screen is visible. So I request all of you, please go into mute so we can have a session at the end for doubts. Okay, so we will discuss the doubts separately. So, this session is regarding monolithic versus microservices and how containers evolved over the time in last few years. Okay, so persons who has more than 10 years of experience, they had seen really a magic happen in applications, how applications were developed and deployed and maintained, tested in olden days. That was really pathetic. So, but nowadays it is becoming very easy. We are able to develop easily. We are able to build and release easily within a few minutes. Earlier, it was taking a few days to build the application and release the application. So we struggled a lot in olden days. Let us rewind those days now, and we can understand better how the applications are evolved from monolithic to microservices. Okay, so this session first theoretical, and at last I will install Docker and I will containerize one application, a simple static website into a Docker container. Then you can understand really how easy it is to convert an application into Docker image or container. Okay. So let us take one example to understand this monolithic and microservices, virtualization, containerization, everything. If you got a job in Bangalore, you need to shift to Bangalore immediately for a few years. So you have to search for some staying place. Okay. So usually one option is independent house. You can go to Bangalore, you can search the place, you can do construction, and then you can start staying in that location. So, but while searching for these options, you have to keep in mind few things, like few parameters. What is the cost of your staying? How much time it will take? How flexible it is, and how easy it is to relocate again from Bangalore to your native place. Okay, so this is a general scenario I'm explaining to relate the monolithic and microservices. Okay, so if you just concentrate on this example, then it will be very easy for you to understand the containerization concept. Okay, and another option is flat in apartment. Compared to this independent house, you no need to search a place and do the construction. You are just recommended to pay for a builder, so everything they will take care. So if you just pay them, they will take care of timing, they will take care of construction, everything. You no need to do anything, just payment. And cost also, it is less compared to the independent house. Another option and easy and flexible option for you is sharing room. Okay, so instead of buying the house, instead of building the house, you can just buy an Nestaway PG where you get I request you all, please go into mute. Okay, so instead of searching for the place, doing the construction, or paying for the builder, you can easily get a sharing room within few days, and you can start staying there. So their bedroom is for you, and remaining hall and kitchen living space, you can share it with others. So compared to these two options in terms of other, parameters, this option is very simple and flexible in all parameters. Cost is less, time is very less flexible. You can easily change from one location to another location, and you can pack up your things and come back to your native place. Okay, so this is very easy, right? So similarly, applications. So when you are developing an application, you need to deploy it somewhere. Okay, so you are developing one application, you need to deploy it into one server. So for that procedure, what you have to do is you need to buy a server, you need to provisioning of a server. It means you need to install the OS, you need to install the application, you need to start the application. And what are the other parameters you can think of is resource optimization. For example, you bought a 16 GB server, but your application is a single application. Maybe it is using mostly 1 GB of RAM. So remaining 15 GB RAM is going to be wasted. And cost, buying a server, installing OS, it is very costly. And high availability. So these are all the parameters we are going to discuss and find the best approach. Obviously, your application you want to be very highly available all the time, 24/7 and reliable. So your application should be up and running. If something goes wrong, immediately your application should provision into another server and start scalable. When there is a high traffic to your application, for example, Amazon Big Billion Day, your application should scale according to the traffic and performance. Your application should be very speed. For example, if Amazon and Flipkart both are announcing Big Billion Day on the same day, whichever application is super performance, whichever application has super performance, then we will go to that application, and of course security. So all these parameters you need to keep in mind while developing and deploying the application for a public sector. For example, Amazon. So let us take this application of Amazon and then start discussing all these features now. Okay. So this entire session we are going to discuss on applications. Okay. There are two types of applications like stateful and stateless. Stateful application means database. Okay, so if you lose this data, you cannot do anything. For example, you are the Amazon owner. You should store the data of who are all the users signed up, who are all the users placed orders, transactions, product catalog. All these things are related to data of your application. Your data is very crucial. If you lose that data, you cannot do anything. But this application, whatever you are seeing in the front end, this is application. This can be stateless, because if Amazon application is crashed today completely, they can easily provision this application again by tomorrow and connect that application with database. But if you lose this database, Amazon cannot do anything. They have to start again from the scratch. So this is what you have to understand, very important in containerization, stateful and stateless. Where your data is very important, that is stateful. Where your data is not important, that is stateless. So our applications are stateless. Even this is crashed, then you can easily provision another application within few minutes to hours. So your business will not be affected. But if you lose the data, your entire business is going down. So these two terms, just understand this, very important. And now let us discuss about what was happening in olden days. The entire Amazon application was a single application. The HTML, CSS, everything, whatever you are seeing here, product catalog, and then orders, carts, payments, everything is a single application. It is definitely more than 500 MB if it in olden days. So we were calling this application as EAR file, Enterprise Archive File. It has multiple web applications, multiple jar files, and you have multiple HTML pages, JavaScript pages, CSS, and then backend technologies. We were using mostly Java and J2E. This is everything a single application of more than 500 MB. And so to develop this much big application, you need lot of developers, like hundreds of developers, and we will have one release date. And for that date, everyone should develop their features. So obviously it will take long time for development. And if the application is very big, obviously it will take too much time to build it properly. If a single small error also can make the application not building successfully. And when the application is very big, it is very difficult to test also. If you do a simple change, you cannot take any chance. You have to test the application again from the scratch and completely. So you are deploying application, you released version 1, to release version 2, again, You have to start from the whole process of development, building, testing, that is even more complex. Okay, so basically we will do if it's a single application, you need to develop everything in a single language like Java or .NET, whatever. And change is becoming very complex as discussed. Now testing also you have to do every time from the scratch completely. Release process also, it was taking hours of process. I still remember in 2012 when I joined TCS, we were building and releasing the applications at midnight. So we will go to office at 6 p.m. and then we will give some announcement at 10 p.m. Application is going to be down now from 10 to early morning 6 a.m. Then we will start building the application. We will moving it to the server. Then we will be stopping the server, restarting the server, doing some sanity checks. All these things, it was taking minimum 1 day time. Okay, so because everyone should be awake at that time, managers, clients, everyone was very tensed about how the release will go. So this is what we were doing at the time, nightmares, because of this much complexity in the application. So to deploy this application also, the servers we had were physical servers. Like you need to, our client should buy the server, we should install the OS, and we should install the application, then we need to start the server. So the disadvantages you can see in terms of these parameters. Provisioning the server is obviously difficult. Every time you need to buy the server, you need to install the application, you need to install the OS. So all these things, high availability, reliability, let us discuss these things one by one. Cost is obviously high. To make it high available, you need multiple servers. So you need to do this process again for every new server. And reliable. So if this server is crashed, then it is very difficult for you to make another copy of the server. Again, you need to buy the server. Again, you need to install the OS, application, everything. And scalability also is obviously, if you announce a big billion day 1 month from now, so you need to prepare all the servers to manage that high traffic. So, and performance security also you need to take care of for each and every server individually. So this is what happening in olden days with physical servers. Okay. And then a new thing came up, RESTful APIs, front end and back end concept. Now we divided the huge, we divided this huge application into two parts. One is front end, another one is back end. For example, this is front end and this is back end. So it has HTML, CSS and JavaScript. It has Java. So these two are connected through RESTful services. Okay, so these are called as REST API. So this Amazon application, all this HTML, CSS, we divided into a separate server. And then this Java-based applications like user authentication, product catalog, cart, shipping. So we have all these modules, right? Order management, payment. So all these things we are keeping in this backend project, and in front end we have HTML, and these two are connected through the REST API. So at that time we got the agile process. So agile, agile. So we will divide the big application into multiple components like this. For example, first we start with authentication and sign up module. First 2 weeks. So this is a single component. It will take 1 week for development. And 1 week for testing and release. So since this is a small component, the first time it will be easy, and the next 2 weeks we will go for catalog, product catalog. So one by one we are going to develop the application, And in this sprint 2, so what we will do is resolve defects of sprint 1. So like that, we were doing block by block, component by component, and at the end, your application will be completed. Sprint N, final sprint, resolve all defects, then release it to public. So this is what happening through the REST APIs. So for that, at that time, virtualization concept came into picture. Okay, you no need to use multiple physical servers. What you can do is you can have one big server like 200 GB of RAM, for example, and 20 TB of hard disk. You can divide this big server into multiple small servers like this using virtualization. Maybe all of you know Oracle Virtual VMware. So using that, you can even divide your desktop or laptop into multiple applications. So here you can have one guest OS. There you can install front end. Here you can install back end. And if for the high availability purpose and for the scalability purpose, you can immediately create another guest OS and install your application. So in this process, we removed two disadvantages like provisioning of server, buying a new server and installing OS, all those things we can remove this part. So earlier it was taking days of time and weeks of time to create another replica of the server. Now with virtualization concept, it became within few hours you can do. So compared just like this physical independent house and apartment, if you need to buy 60 independent houses, it will take too much time. But if you need to construct 60 flats, it will take very less time. So similarly here, provisioning of multiple servers for scalability and reliability, it is taking very less time, maybe in hours, using this virtualization concept. So, but still there is a disadvantage, you know, right? Still this application is it is becoming 250 MB maybe or 400 MB because of these many components. Now this is becoming 100 MB. But still this application is very big. All of the things are in a single project. All the backend is in single project. Again, we have these disadvantages of developing in the same language. Change also is becoming very tough. And when the sprints goes on, your complexity is becoming increased. So now what happened is we got microservices. Microservices is nothing but, this is a big project. Divide big project into multiple components. Now here, all the components are in a single project. This is a single project. Now we have user project separate, catalog project separate, everything is separate. So these, okay, let us take. So now this is front end. And this is microservice of user. This is microservice of cart. This is microservice of payment. This is microservice of order. So all these are connected through the APIs. So with this, what you can do is, you don't need to develop every application in a single language. You can have multiple languages. For example, to develop this much big Amazon, you cannot hire 1,000 Java developers. You can hire few Java developers that takes care of user project, and few Python developers that takes care of cart project, and few Node.js developers. So you can use basically any language to develop the applications. So these applications are loosely coupled with APIs. Okay. So now this application will become 50 MB. This application will become 50 MB. This will become 50 MB like that. So now we have the parameters, right? So development is becoming very easy now. Okay, now the development is becoming very easy because user project developers are not dependent on cart. Okay, they can do their own development. And then building. So since projects is very small, so less time and less complexity. Okay, just simple. To construct a very big house, it will take more time, more complexity. To build a small house, it will take less complexity. And then deployment, same, less complexity. And testing is becoming very, very easy now. You don't need to test the entire big application. Just test this component. Changes. If something goes wrong in this cart, if something goes wrong in this catalog, you will only change that catalog project. You will not change the entire application. Okay. So the biggest advantage is if it is a single application, if something is wrong in like this product, while you are searching for this product, if this product is not available, then the entire application will go down. Okay. So this is the major advantage of microservices. Error in single component cannot make the application down. But in monolithic, entire application will go down. Okay, so that is the biggest advantage with microservices when you divide it into when you divide a big project into this multiple components. So of course you need to take care of this communication. So this user should be able to call the cart should be able to call the order management. This communication is a little challenging. This is the only challenging part. So of course, when you are getting more advantages, you need to take few challenges. So the challenge here is the communication, proper communication between these services. Okay. So now to deploy this application, so when your application was very big, you need a big server like 4 GB RAM, 16 GB RAM. But when your application is in MBs, you don't need to buy a big server. For example, here, if the RAM of this application is 4 GB, you don't need 4 GB application to run a single user component. You need maximum 1 GB RAM. But here 3 GB is going as waste. So that is where resource optimization is the biggest disadvantage in virtualization. So when you are facing interviews about virtualization versus containerization, the first disadvantage you need to tell is in virtualization. So we have the resources going as waste, but in containerization, we can effectively use the resources. You can basically use all resources of your host effectively. And here, provisioning of new server, installing the OS, and then installing the application, again, it will take hours of time. But when your application is just 50 MB or 100 MB, it should not take that much time. Okay, so that's where containers came into concept. So you know here how flexible it is a sharing room. If you want to join in any PG, you can join immediately. If you want to come out, you can come out immediately. And you have all the basic amenities. You don't need to search for all amenities like kitchen, living room, and hall. All those things you don't need to search. Everything is ready-made available. So similarly, these containers are very flexible. For any application to run, we need just OS and few packages and your application dependencies and your application artifact. For example, if you buy a laptop, if you want to use it for a specific purpose, like just use it for official and office purpose, you will not install any VLC media player, you will not install any games, right? So purpose, your laptop purpose is just like office. So what you do, maybe you will use Windows OS and you need MS Office. So that's it. If your laptop, if your intention is only to do the office work, you don't install games, you don't install VLC, you don't install studio apps. So all those things you don't install, right? You will not install Chrome browser. So when you are installing multiple things into your server or your laptop is going to take too much memory, too much time. It will eventually become slow. But for us, like a user project, it is a very simple project, simple application. I need one bare minimum OS. I don't need extra packages, extra installations. I need bare minimum OS, few system packages or commands, you can say, and application runtime. For example, if you are running a Java application, I need JRE environment. If you are running a .NET application, I need .NET environment. If you are running Python, I need Python. That's it. Application runtime and your actual libraries required by your application and your actual application artifact. So that's it. You don't need the full OS features like I don't see here. I'm using Visual Studio Code. I'm using MS Paint. All these things you don't need to run a simple application. So for that purpose, we have the containers concept. In your host OS, you install Docker, and here it will be called as image or container. So what is a container or what is an image is, a container or image consists of bare minimum OS, system packages, and your application runtime, libraries required by your application. Here also system packages, commands required by your application only. We don't install unnecessary things and actual application. So these few things you will do, and then you will ship it as a Docker image, all these things. Okay. And when you run Docker image, you will get container. Okay. Similarly, you know, right, our OS is like ISO format when you are installing Windows or any Ubuntu OS into your laptop. This is called as image, OS image. When you run this, you will get your OS runtime. So similarly, this is Docker image. When you run this, you will get Docker container. Okay. So why I told this big story is earlier, our applications were very complex so that we had to buy physical servers and do the all installations and installation of application, OS, everything. Later, it became little easy with virtualization concept. We were not required to buy many servers. We can use single server with hypervisor and virtualization concept. And then we were able to deploy the applications within hours from days. Now with containers, you can deploy, you can scale, you can test the applications within seconds. Okay, so that is the advantage we have. So one thing you should remember is whenever you are running an image, you don't do any unnecessary installations. Okay, so in our Windows OS also, they can pre-install my MS Office, they can pre-install VLC, they can pre-install many different softwares, but they are not doing because it is changing. It will change for based on individual. Okay, so that's why to deploy microservices, we need these things only. Okay, so now I can pass for some time and let us have doubts. So anyone can unmute and then you can ask doubts. Hello.
Yeah, good evening.
Yeah.
You know what is the bare minimum OS mean?
Bare minimum OS means, for example, our Windows OS is like 2 to 4 GB, right? But there is one OS called Alpine that is 6 MB maximum. And you know, there are some devices called Raspberry Pi, chips used in as sensors. So in this sensor, this is like ATM card size of computer. So in this, we will install very bare minimum OS. It will not give you any graphics. It will not give you any unnecessary softwares. It is only useful to run your hardware. So that's it. So that is called as bare minimum OS. If you have a graphical user interface, obviously your memory will be more, right? So we will reduce in our Linux environments. We will not have any graphical user interface. So more memory is reduced and we only have command line and we don't install any unnecessary softwares. So just that OS will be used just to run your hardware, processor, all those things. That's it. Yeah, hi.
Yeah, hi. So I wanted to know about the hypervisor part, like the virtualization diagram. So you mentioned hypervisor, right?
Yeah.
So I wanted to know about that. Because host OS I understood, guest OS I understood.
Yeah, this hypervisor is a concept from virtualization, like VMware ESXi. There is a separate technology. So many person like VMware admins. So we have one software that will logically divide this big server of like 400 GB RAM and 20 TB hard disk into multiple small servers, and they will give you access. So this server they will give for one project, this server they will give for another project, this server they will give for another project, and provisioning of the servers becoming very easy. So this is a different technology, VMware concept. So when you are provisioning a server in AWS, it means AWS is creating one server using hypervisor, and they are giving you that access.
Hi Shiva, when you say bare minimum OS, where do we get them and who builds them?
Yeah, so that will be from different vendors. For example, if you go to the Docker Hub, so there will be always official vendors to give that bare minimum OS. For example, CentOS you will do, that is very big when you are applying it for servers, but CentOS can officially give you one Docker image that is bare minimum. Okay, I'll show you now. I'll show you everything in a practical way now. So this containerization concept is completely different. So every person who is developing the OS like CentOS, Red Hat, Fedora, all Ubuntu, every guys in the market officially developed those Docker images and then they push to Docker Hub. You can now start using this. So why I said all these stories. Nowadays, every application is migrating towards microservices. No one is developing very big projects like I shown earlier. Everybody is developing projects into microservices. So Amazon is completely microservice. Every 11 seconds, they are doing one release. That is because of independency. So there is no dependency between all these components. Anybody can do whatever they want. Okay. So when you are able to release features with less defects, then your application or your project, your company will become more success. So as a user or as a software engineer, your goal is to only two points. Release features very fastly compared to competitors. And then less defects. So these things are possible when you adapt microservices. When you adapt microservice, then containerization is a mandatory concept you should learn. Okay. So now I will show you one application. Now this is a simple application. I deployed in this laptop. Okay. So to deploy this application, I need one laptop. But instead of this laptop, you can do it as a container. For example, I have provisioned one server. I install Docker here using these commands. I install Docker. Let me change this appearance. Okay. So here, if you see Docker file, so I'm downloading, this is a OS. This is an OS called Alpine OS. Maximum it is 6 MB. Now, if I build this application as a container, because you need to learn all these things with Docker and Kubernetes, but I'm just showing as a practical.
Seems screen is done.
Okay, one second, I'll reshare it. Okay, you can see now. This is the OS, Alpine OS, maximum 40.7 MB. I was just showing one Docker file. How can you create containers? Okay. So this is maximum 40 MB. The entire server, you can say, the entire OS, it is 40 MB. And I install one application called QI in this, that is 3 MB. Now the entire application, all this part, this entire part is becoming 43 MB now. Okay. But if you have to deploy this application into a server, that will take at least 1 GB RAM and 2 GB hard disk. So all these things you require. But now in a single server, I will deploy multiple applications like this. Docker run -d -p 8080. So don't worry if you are not able to understand these concepts. Just I want to show a demonstration on this. So now your container is running. This is your container running. If you open this one, in the browser, now you can see the application running within few seconds. Now, if I want, if for example, I'm getting too much traffic, I want to create another one. You got it, another application immediately running on 8080 port. Okay. Similarly, you can run as many applications as possible. 8081, 8082. Now, if you see, your application is 4 applications are running within few seconds. Okay. So many instances of your application is running within few seconds, within just, this server is 1 GB RAM and 8 GB hard disk. So you can run at least 10 instances of this application. Okay. When your traffic is getting more, you can increase the number of instances. When your traffic is getting less, you can remove it. Okay, that is the advantage. Speed, deployment, testing, everything is very becoming very advantageous in this containerization concept.
That can we do automatic, Shiva?
Yeah, we can do automatic. So that's what we learned, right? So everything can be done automatic. You don't need to touch anything. So
coming up the Dockers automatically, if the load is less, it go off automatically. That can be possible with the Docker, sir.
Yes, that is possible. That is called as auto scaling, right?
Yeah, auto scaling.
So auto scaling is possible at each and every level. So recently there was an AHA issue, right? So when traffic is getting more, applications were not able to scale. I mean, AHA was giving error. But if you do this procedure with containerization, I am sure they implemented containerization, but there were a few defects while handling too much traffic. They should haven't done it properly. So we need 2 types of auto scaling at server level. So this server maximum it can run 10 containers. If you are getting more traffic, then you need to create another host OS. Again, you need to install Docker engine. So like that. So this is a server auto scaling. And when you're running another server, again, you need to auto scale your containers. So there are 2 levels of auto scaling at server level, auto scaling at container level. So these 2 applications you need to implement properly to handle high amount of traffic. So in this last 10 years, many things got changed. Yeah, hi. Good evening. So you can see now this application consider it is developed by developers. This one QI, index, details, and then assets, CSS, everything. Just now you saw that, right? Within few seconds, I deployed this application into a server and it was up and running. So similarly, when it is a complex application also, you can use this Docker and Kubernetes to run microservices. Yeah, now can someone ask the question?
Good evening,
Yeah,
sir.
hi, sir.
Yeah, good evening.
Good evening.
Sir,
Yeah.
my name is.
Can you give me?
Sir, to automate the process, we have to write code, right, sir?
Yes, you need to write things like this. So for example, this is the e-commerce application we are going to learn in this Docker and Kubernetes course. So at every time you need to write some Docker file, build the image, push it, and make the connections happening.
Sir, Python is required to write the code, or else shell scripting is okay?
No need of shell scripting. This is completely Docker. Simple instructions are enough. These instructions like from These are enough. Copy, run.
Okay.
So you don't need
Okay.
shell scripting, but if you have a knowledge of Linux and shell scripting, that is always better for anything in DevOps and cloud sector. For any technology in this IT, Linux and shell scripting are basic. If you know those concepts, you can understand any technology in a better way. So I recommend those.
Regarding Python, sir, Python
Python is not required. Python is not required. We don't require any coding for this. We need to know how can you create Docker images, how can you run it as Docker containers, how to provision Kubernetes cluster, how to deploy applications into Kubernetes. All those things you need. So to run a thing, yeah.
You said that we can create a containers and we can install them apps in containers, right?
Yes.
So suppose if the container got crash, then how the other container can gets created?
Yeah, so we will be monitoring automatically. So all these features are available within the container technology. If something is crashed, Kubernetes will continuously monitor it and immediately it will provision into another server within seconds. So for that, we have health checks. There is a concept of health checks. We will configure them. Kubernetes will continuously checking the health of the container. If something goes wrong, it will immediately provision it into another server. So that is why it is called as reliable. Reliable means it is guaranteed. Whatever happens within the Kubernetes cluster, if some server goes wrong, immediately it will provision it into another server. So that is called reliable. Obviously, highly available. I was showing you we can do auto scaling to make the application running, and scalable. When the traffic is getting more and more, automatically it will scale, automatically it will scale down. Resource optimization, you just now saw this. Within one server, I created 4 applications.
For security, what will be there for application
security? Security is less in container technologies. This is the disadvantage. We need to follow few approaches.
Shiva.
Yeah, hi.
Yeah, hi. Could you please help with us like a small diagrammatical scenario or how different than this monolithic versus microservices?
Okay. So earlier I shown you, right? This is the one biggest project here. Everything is in a single file. Now we divide it into multiple things. User is a simple project, card is another project, order is another project, payment is another project. So like this, I can even show you here. So see here, this is a simple application. Cart is one application, catalog is one application. But if it is monolithic, it is a single application of RoboShop. So this is one application. If it is monolithic, if it is microservices, these are all very different. Like this. This is front end. This is another application. This is another application. This is another application. So each one person can take care of this application.
Good evening, sir.
Yeah.
Okay. So then, what is the main achievement of going through microservices than monolithic here? Are we cutting the cost, or are we saving the developer activity?
Everything I was explaining, the complete stories around this one.
Good evening, sir.
Cost is reduced. Yeah, hi, good evening.
Sir, my name is Sai, sir.
Yeah, hi.
Sir, how many tools in DevOps, sir?
Okay, so this is related to Docker and Kubernetes. So we will discuss only this thing, Docker and Kubernetes.
Sir, each microservice is installed in each container, or
yes,
whole
one
application
microservice is one container. One microservice is one container.
Shiva, hi.
Sorry to disturb. Yeah, Shiva, coming to the actual point, you are saying high availability, right? So in this case, So we are using high availability means we need to get one more containers like entire
Yes.
setup. Right? So
Yes.
that is waste of our services, right? I mean resources. So it will be constantly ideal until unless suppose first image what you are shown right just now. So that is keep on running. When issues happen, then only it will be do high availability, right?
See, high availability means if one container goes wrong, another container is available to serve you the traffic. Okay. Scalability means when the traffic is getting more and more, you need multiple applications. So we will create multiple containers. When the traffic is reduced, we will immediately remove the containers.
Okay.
See, high availability means at least you should have 2 instances. If one goes wrong, another one is available.
Yeah, in this case, one instance is up and running, another instance is ideal, right? Until unless we use that.
Yeah, if you want high availability, you need it. Otherwise, you can remove it. It's up to you. See, project is based on the business requirements. Okay. If you are doing a project in your hometown, obviously your hometown is very less people, you will not get the traffic continuously, right? But if consider Amazon is getting huge traffic, lakhs and crores of requests across the world. So obviously they need high availability. They don't care about 100 rupees more per one day or 200 rupees more per one day or lakhs of rupees for one day. Their business should not affect. So this is completely based on the project business requirements. Based on that, you can flexibly do it anything you want.
Hello, Shiva.
Can I add a small example here with your permission, Shiva?
Yes, please.
Let's suppose, guys, so we'll travel, like we'll book a tickets on the festival season, right? So
Okay, so lost his voice. I got his example. In the festival season, you cannot expect the traffic. Suddenly traffic will become more. So at that time, these containers will be easily scalable without any human intervention. Okay.
Correct.
So DevOps engineers, developers can sleep happily at the night time as well. But in olden days, we were not that happy. Yeah.
What
yes.
Kubernetes will do, Shivagaru?
Sir, regarding
that's the right question. What Kubernetes will do when your containers are becoming more, for example, if you have 1,000 containers, like I logged in here and then I was running the commands manually, right? But with Kubernetes will manage the containers. So like human, it will do the monitoring of traffic. It will be keep on checking the servers. If one server is going down, immediately it will scale the application. Immediately it will move the applications into another server. Everything, container management will be done by Kubernetes. Like our manager, suppose you have 100 team members, there should be at least one manager who can distribute the work to the developers, testers, all those things, who can monitor what someone is doing. So similarly, Kubernetes is a container orchestration technology that is mandatory to manage the containers.
Yeah, that's correct. That's correct.
Yeah, for example,
and one more thing.
For example,
I can simplify. If with
already
permission, I can simplify this scenario.
Yes.
నేను ఆల్రెడీ AWS లో వర్క్ చేస్తున్నాను శివ గారు. అండ్ DevOps అసలు వర్క్ చేయట్లేదు. ఇప్పుడు ఈ డాకర్ క్యూబర్నెటిస్ నేర్చుకొని రేపు క్యూబర్నెటిస్ మీద నేను రెజ్యూమ్ ప్రిపేర్ చేసుకొని వర్క్ చేయగలమా?
I'll add the scenario.
Yes, you can. So persons who are working as DevOps engineers, cloud engineers, developers, you can add this technology to your profile that will add the weightage.
Sure,
okay, you are a cloud engineer. Now you should know how to create EKS cluster, how to deploy applications into that cluster.
Yes. అసలు యాక్చువల్లీ నేను ఫ్రెషర్ ని ఇంతవరకు ఐటీలో రాలేదు, ఇది యూజ్ అవుతుందా?
See, I cannot say it whether it will be useful or not, but this concept, this technology is mandatory in any part of the IT nowadays because everything is becoming microservice. I don't care whether you are fresher or whether you are experienced. I have a project running. You join to my project. If you understand this technology, that will be helpful for you and helpful for me as a project manager as well. But if you say I am fresher, I cannot learn this, then still fine, but your career will not be that much successful. So don't have a question of like, I'm a fresher, I am just 2 years experience, 3 years experience, can I learn this? If you have a capability to learn, definitely you learn it.
Hi, Shiva.
See, for that purpose, so here there is a front end, right? All the requests from browser will come here. So then this front end will send these requests to, for example, if you are logging in, then it will send a request to the user module. If you are searching for a product, then it will forward that request to this catalog service. Okay, for example, this is a catalog service. So you need to do those configurations. That's what we learn. So that's what we learn. How can you configure front end? How can you configure all these microservices? How can you make these connections successful? How at the end of the day, how can you run this e-commerce project successfully into the browser? All those things we will learn.
Hello, sir.
Yes. Yes,
hi,
someone
Shiva.
was asking a question. Yeah, hi.
This is Mahesh.
Yes,
Like
Mahesh.
I work into production support.
Yeah, okay.
So I just want to know, like, what is the amount of scripting expertise that we need to have to do a DevOps, to pursue the DevOps?
See, you are into production support. You need to check the servers whether they are running fine or not.
Yes.
Suppose I will ask you to monitor. If you are smart, you can write a script. If something every 10 seconds, it will check whether the server is running or not. And then you can do your other work. If something goes wrong, you will get alerts.
Yes.
Otherwise, you have another option. You just see the system continuously and every 10 seconds refresh the page. If something goes wrong, then you need to report to the manager. Which one is better?
Yeah, automation. Definitely the automation.
Yeah, definitely the automation. Automation comes from scripting only.
Okay.
So every technology nowadays is moving towards scripting. We don't want some person we don't want some human errors. We will trust machines. We will trust scripts than humans, right? So scripting is mandatory in any technology. If you are a DevOps engineer, shell scripting is mandatory. If you are a database engineer, SQL scripting is mandatory. If you are a data science engineer, Python is mandatory. So everywhere scripting is mandatory. Okay. So any other questions? Hello.
Hello.
Yes.
Hi, sir. Good evening.
Yeah.
Sir, actually, we create Docker images, right, with the help of Docker file.
Yes, correct.
For creating Docker file, do we need to install the dependency, or we can just create the Docker file automatically?
Everything we will install here inside Docker file. Okay. So whatever you require, everything you will do it here. For example, see here, I'm installing something. So you do every installation in these things, in these few parts, and you ship it as an image. And that image is your application. If you run it 10 times, you will get 10 applications, 10 instances of your application. So this technology is mandatory. But as a DevOps engineer, everyone, so that's why I designed this course to fill the gap of you learn all these things of Docker, writing Docker file, creating your own image for your application, understanding the Docker architecture, how can you convert a web application into Docker, and then finally we will discuss the disadvantages of managing Docker containers. Then we will understand the need of Kubernetes. Then we will discuss Kubernetes architecture. So all these things we should learn. as part of this technology. So finally at the end of the course, you are capable of creating an application as image containers, deploying into the Kubernetes cluster, setting up the highly available and everything you can do. High availability, everything, auto scaling, everything you can do. So that is where it is very useful. So this session, I just wanted to show you how important this technology is. Okay, nowadays everything is microservices. So you can find someone who is teaching DevOps, even we teach DevOps and cloud, but we were not able to concentrate completely like this 25 to 30 hours in DevOps engineering course or cloud engineering course or development course. So because this is a little bit advanced, you cannot mix it with the Java development, you cannot mix it with the DevOps, you cannot mix it with the cloud. You should learn it in depth. So that's why I started this course.
Hi,
with these guys. Yeah, hi.
Yeah, this is Radha. So my understanding is when we have this virtualization concept and this REST API concept came, so this is like how application is divided, like front end and back end. Then we deploy these applications using the virtualization concept. And coming to the microservices, then again application is divided into each and every individual piece, and these microservices we deploy using containers. So these two, is my understanding correct?
Yes, your understanding is correct.
Because there is a disadvantage in virtualization, microservices concept came.
Yeah, correct. See, virtualization are still useful for infrastructure. Like this instance, this instance is created with underlying virtualization concept. Okay, but as a user, as a software engineer, you don't care how this instance is created. But as a developer or DevOps engineer, I need these things. How can I create containers? So this technology only will be taken care by VMware guys. But this technology of containers, developers, DevOps engineers, support engineers, everyone should understand this concept now.
Yes, got it.
So you can see one single server becoming multiple servers, now becoming hundreds and thousands of containers.
Yes.
But the number of servers are not that much increased, right? So here, if you want to deploy 100 applications, you need 100 servers. Now here, maybe you need 10 servers. Maybe here you need 2 or 3 servers.
Yes. So here the OS, guest OS we are eliminating here, so that underlying service will become less.
Yeah, performance is increased, and the provisioning boot up is also very high. For example, suddenly your application got 100 to 1 lakh users of traffic. In case of virtualization, it will take at least 1 to 2 hours or 3 hours for it to scale. But here, within seconds, it will scale.
Yes. Okay, sure. Thank you.
Yeah. So that's why you should learn this topic as per business requirement. So if you learn this technology, you can add this technology to your existing skill as DevOps engineer or cloud engineer or support or development, everything you can add this technology. Or individually also you can become Kubernetes administrator. And you can clear CKA certification that is very highly valuable.
Hello, Shiva.
Yeah, hi.
Currently in morning sessions, we are doing with Terraform, we are creating resources, right, in cloud.
Yeah.
Like that, can we create even containers also?
We can create infrastructure using Terraform. We can create this EKS.
Okay.
EKS cluster we can create. Only infrastructure you can create using Terraform. You cannot create applications.
Okay. I mean, containers means for
container means application.
The container, right?
Yeah, container is application. There are 2 parts for everything. One is infrastructure. So this comes under like servers, platforms, all those things. Another thing is application. To install an application, first infrastructure should be ready. Now I need to install this Kubernetes pods or Docker containers. Where should I do it? I should have some server, or I should have some cluster, right? So that comes under infrastructure part. This comes under application part. Okay. Yeah. So any other questions? See, anyone, you no need to wait for me. You can unmute yourself.
Oh, sorry. Hi Shiva, Satish here this side. Like how we can differentiate containerization versus pod?
Yeah, pod and container almost same, but in Kubernetes we call it as pod. One pod can run multiple containers. So that when you are going deep into the technology, you can understand. Mostly same. Pod can have multiple containers. That's the only difference.
Hello.
Sir, regarding scalability, sir. So how we will come to know, sir? Suppose minimum is 5 containers and maximum is 12 containers. How we will come to know, sir, that regarding scalability?
You first provision one container. Then you have a condition of if the CPU utilization is becoming more, or if the number of requests are becoming more, obviously your utilization of the pod will become more, right? Pod or container. Then you will write a condition. If the present container is 80% utilized, create another container. Maximum up to 10, 1 to 10. So it will continuously check the utilization of the existing containers. If it is reaching 80%, then it will create another container. So those conditions, that is what auto scaling we will practice and learn in this course.
Yeah, Shiva, this is Praveen.
Hello.
Yes.
Hello. So in this course, are we going to cover the Istio policies, network policies, ingress?
Ingress, egress we can cover. Istio we cannot. So that is not covered in this.
Network policies?
Yeah, network policies are covered. Yes.
Okay.
Yeah, that's what my question also. We have networking concepts and security concepts, service mesh, API gateways. Some of the complex concepts are there. Will you cover those also?
That Istio itself is like another technology on top of this. But first you understand this, then we can implement it. But this one we cannot cover Istio completely. We can just give an introduction because that itself will take another 20 hours more.
Hello.
Yeah. Hi. Yes.
Because that part is also required for the CK certification, I guess.
No. You don't need Istio part for CK. Istio is completely different. For some Kubernetes cluster, you don't need Istio at all. So that is adding more complexity. We never used in our old projects, we never used Istio. So nowadays, maybe you are using
image scanning in this Kubernetes course.
What? Once again?
Do you cover image scanning?
Yes, we can cover. ECR in cloud, we have the default feature available that will scan the images. The scanning is nothing but it will scan and it will give you vulnerabilities. You need to carefully remove those vulnerabilities. Yes, please.
By attending this Kubernetes course, how much experienced candidate can we become in Kubernetes technology?
If you practice it many times, you can showcase 2 to 3 years of experience.
Only Kubernetes? No, only Kubernetes you can do 2 to 3 years?
In interviews, they will ask you what is the difference between. Yeah, I'm saying relevant experience 2 to 3 years if you practice completely, whatever I say.
Okay.
So they will ask you write a YAML definition to create a pod, to create a deployment.
Okay.
So they will ask you how can you create scaling, horizontal pod, autoscaler, all those things they will ask you. So then if you practice well, then only you can, otherwise you cannot.
Okay. how many projects should be put in only for Kubernetes?
If you learn this Docker and Kubernetes, the procedure is same for any number of projects.
For 4
Tomorrow,
years
if you
for 4.6 years experience.
See, that is based on your confidence and based on your practice.
Okay. Actually, for only 1 year for one project, or only 2 projects can also.
See, actually, if you know this concept, you can run 10 projects parallelly at a time.
Okay.
Because procedure is same for anything.
Okay. Thank you.
Yeah, could you please elaborate briefly what are the concepts might be covered for the exam CK?
Whatever I have written here, these are the concepts only they will ask you in CK. So they will ask you, how can you label it? How can you do the sidecar patterns? Write a replica set. All these things they will ask in question in exam. Write service, write a Kubernetes service. So all these things they will ask. So that's what we are going to learn here.
Yeah, I have my only one major doubt is that if they ask this service mesh API gateway, some other networking concept, that's
not
what my
there.
doubt
You
is.
can no, you can check in the CKA syllabus. It is not there.
Okay. Hi, Shiva.
Yes.
Actually, linked.
Okay, so this
లొకేషన్ సెర్చ్ చేసే ప్రొఫైల్స్ వస్తున్నాయి. ఆ ప్రొఫైల్స్ బట్టి మనము సెర్చ్ చేసి క్యాండిడేట్ కి ఫోన్ చేసి ఇంట్రెస్టెడ్ ఉంటే మనం ఆ ప్రొఫైల్ అప్డేట్ చేస్తాం. లేదంటే
okay, so you can buy this
ఇప్పటికైతే
using this link, and I have asked to create a separate promo code Siva45 to give the maximum discount. Okay, you can use this Siva45 to get the maximum discount. Okay. So I requested for very, very low price.
So they create, but candidate too, most of the people interest open to work and ready to willing.
So anyone, you can buy this right now. It is only available for some time. So I specially requested those guys using this enrollment link and this code Siva45. That will give you the all-time low price. So that was my personal request for them, because this is the course I'm launching publicly, because I didn't find this course anywhere in the market. Okay. Any questions? Final questions?
Hello. Hi, Nadish.
Yeah. Yes. Hi.
Understanding like whether it's easy to allocate the memory.
So technical questions, too much deep technical questions we may discuss inside in the course, but this is not the right time to discuss. There is no end for it because it's a in-depth course.
Now the course is available, huh? Hello.
Yes.
Yes, sir.
Is this course is enough for applying for jobs?
See, as a Kubernetes administrator, you can apply with this knowledge. If you are not working at all now, but if you are working into some other technology, you can add this course.
Okay, like that I'm working or I have knowledge.
What is your current technology?
Current I'm working in storage.
What is it?
Storage.
Okay, SAN. Okay, SAN is becoming obsolete right nowadays. Very less openings on storage because everything is moving to cloud. So if for example, if you have 5 years of experience into SAN, you can tell them last 2 years, I started working on Docker and Kubernetes. Previously, I had storage experience. So I upgraded to Docker and Kubernetes as part of career upgrade. So that's what you can say.
Okay. Is this, I mean, like your course is enough for me to upgrade?
Hi, Siva.
Yeah. This is enough to become Kubernetes administrator. If you want to become DevOps engineer, you need to know DevOps and Kubernetes both.
Okay.
Thank you.
Hi, Siva.
Yes.
Hi, Siva.
Yes. Yeah, hi.
Is there any interview support added in this course? Or
in the
probably on the question side, or
in the course, while discussing the concepts, I will be giving you what are the interview questions around that concept. For example, there are a lot of questions in Docker. While learning here Docker file instructions, I will discuss what is the difference between add and copy, what is the difference between CMD and run command, what is the difference between CMD and entry point. All these questions are asked as part of interviews. Like how can you write multi-stage builds? All those things are asked as part of interview. We will discuss those things, like how Docker imaging layers. So while learning the concepts, I will discuss the interview questions as well.
Hello.
Yes.
Can you cover CI/CD with respect to Kubernetes interview questions?
CI/CD we cannot. That's a huge topic.
Okay. My interview perspective actually after.
So if you are interested in CI/CD, you should learn DevOps as well.
Yeah. Okay.
Why is this on only weekends or it's on regular
It's
classes?
on weekdays, Monday to Friday.
Course will be on weekends. Someone written it's on
No, it is on weekdays, Monday to Friday.
Okay.
Shiva, I have enrolled this course and daily I get recorded sessions. So sometimes
Yes, this course is completely recorded for lifetime. You can anytime come to this website, log in, you can see your courses.
Yes, I have enrolled.
We will have chat sessions also. We will have question and answer session also. Everything is recorded. Everything will be available. Yes, this is.
Sorry, Siva, sorry to interrupt. Like I lost you in between. Actually, I was already enrolled for this session. Like, will I be able to get this separate link for joining the session? Like, I am currently working. I was more
yeah,
interested.
you will get all the details to join for the course, session links, everything. You will get it. Like now, how you join this session. Similarly, you will join daily sessions.
Okay, perfect. Like if I missed a session, like currently I'm working, that's the reason.
You will have a recording.
Absolutely. Thank you so much, Siva.
Yeah.
How many days?
So this will take 1 month. This will take 1 month to 40 days, 25 to 30 hours. So maximum 40-45 days maximum. Okay.
Monday to Friday.
Yeah, Monday to Friday.
Okay. Thanks.
Hi, Shiva.
Yeah, I posted this anyhow. So yeah,
Shiva, in this course, you are going to teach only EKS part of Kubernetes or manual installation of
Kubernetes is same across cloud, on-premise, everywhere. Okay. So I will explain the Kubernetes architecture. We will do installation into on-premise as well.
Okay. After that, we will do in EKS also, right?
Yeah, we will do EKS as well.
Hi, sir. This course is teaching by you only, sir, exclusively, or else any other partner?
No, I will teach.
I see. Okay. So, sir,
so you can use this bit.ly link. You can use this bit.ly link, and this is the code Siva45, or else you can come to our website and you can use this code to buy it. Okay.
Okay, sir. Sir, if I learn only Docker and Kubernetes, will I get any job, sir? Only Docker?
Yeah, you can try as Kubernetes administrator.
I see. Okay. Thank you.
Shiva, we can only get CK knowledge, right? Not CKAD here.
CKAD is subset of CKA.
Okay.
So CKAD is level 1, CKA is level 2. You can do both, or you can do only CKA.
So with this training, we can give a try for CKAD also.
Yeah, you can do both. If you are able to clear CKA, then you can definitely clear CKAD as well.
Okay. Yeah, thank you.
Shiva, just now you told me like for DevOps we need to learn some other tools, right? So
yeah,
from your perspective, which one is better, like DevOps engineer or Kubernetes administrator?
See, Kubernetes administrator, if you know, that is good. If you learn multiple technologies like DevOps and Docker and Kubernetes, then obviously you are more preferred, right? There are few jobs only Kubernetes administrator. For example, in an organization, there are obviously persons who know multiple skills are preferred. So that's why I was saying add this technology to your existing skill. If you have some experience, I'm sure all of you may have some experience, right? Into some technology. So add this technology. Or if you don't have any experience, learn this and try as CKA, Certified Kubernetes Administrator. Okay, so we had 1.5 hours of session. So I hope I have given good introduction on how applications evolved from monolithic to microservice. What is the need for Docker and Kubernetes nowadays? Okay, so if you do this CKA certification, definitely you will be preferred for interviews and openings. Okay, so if you want to enroll, you can use this link. I pasted already in the chat, simple bit.ly link, and then you can use this Shiva 45 to get the max discount. So that's all for today. Thanks for joining.
Thank you, Shiva.
See you on March 4th. Good night. See you all. Good night. Have a nice day.
Thanks, Shiva. Thank you.